Hello guys. I thought we'd do some different subjects to do sequences and series. So we'll start with arithmetic progression. If you're wondering what this is, don't worry. Well, I'll show you now. So, what is it? It is a sequence of numbers starting at a number of a, which increases by a factor of d. So, if we take an example there, so 13579. So the first number of any sequence is a, and usually the sequence increases by a constant of d. And this constant of d applies throughout the whole equation. The only one it don't apply to is a, because everything you add to that, so a plus d, a plus 2d, a plus 3d, a plus 4d, etc, etc. So if we look at the example above, a equals 1, since that is the first term of the equation. And we can work out d by minusing one of the terms with a term before it. So, for example, 3 minus 1, since that's the second term, 3, and the first term is 1. So 3 minus 1, same for 5 minus 3, that's the third term minus the second term, etc, etc, and it comes out to 2, which makes sense because you can see how 13579 is increasing by a factor of 2. So the general formula to find a value at the nth term. The nth term, so if you think about the nth term, the first term, second term, third term, fourth, etc. You want to find the value, which is the un at n. So at n equals 7, you want to find the value of this arithmetic sequence. So yeah, un is the value of the n term. Is value of is the value at the term of n. A is the first value, the very first value of the very first term. N is the nth term, so whenever it so n equals 1, n equals 2, n equals 3. And d is the constant at which the sequence is increasing or decreasing. I just went with increasing because you can represent, you can say like a sequence is increasing by a factor of -3, which is a bit, sounds odd, but it's legit mathematics. It just means you just put a minus in front of it. If you were saying a constant at which the sequence is decreasing, so and you said by 3, that would be like -3, if you know what I mean. So yeah, you can use whatever notation you like. It means the same thing if you use it the right way around. So we'll just do an example then with this. So this is a bit simple, I guess, but generally what happens is the question might ask you what. So if you have a value, if the first term is a certain number and it has a difference of, I don't know, of d, work out the nth term, or work out the 8th term, the 16th term, whatever. So, and you just have to plug it into this equation. So if we just look, yeah, so 2 is a and 3 is a difference. So, and if we try and find the 5th term, we just stick in 5 into the where n is, because that's the 5th term, and then crunch the numbers down. So it equals 14. Now, if we look at that as a AP, or arithmetic progression, goes 2, 5, 8, 11, 14, 17, 20. The 5th term of that sequence is 14, which is highlighted in, if I get a pen out, yes, which is here, 14 here. So that's that one. So for this, so if I wanted to work out the sixth term, I can just stick a 6 here instead. 6 minus 1. 6 minus 1 at 5. 5 times 3 is 15. 2 add 15 is 17. And then that'll make 17. So yeah, it's as long as you follow the equation properly and you crunch it down right, you can get the number easy. So the next one, if you try to find the sum of a arithmetic progression, then this is the general formula. So Sn is just the sum of the AP up to the nth term. So you notice that there's an S, so that S is just means sum, and then n, the lowercase n, just under it, is the up to a point where do you want to find the sum of? So do you want to find the sum of between the first term and the fourth term, or the first term, or the to the 1000th term? And as long as you follow this and it's an arithmetic progression, then that's fine. It will always give you the correct answer. So, and L is the last term. Now, the last term, if it tells you, for example, if you want to find the sum of an AP to 1000, n equals 1000, you would stick in that other formula we just found out. So you find the term at that number you're trying to make the sum of. I'll show you in the next one, because you can write the equation a different way. So if we look at, it says since L is the last term, is the nth value of an AP, then the sum of an equation can be rewritten as, so n over 2, 2a add n minus 1d. Now what I've done basically, I've just substituted L into that equation, so you can split it down a bit easier and you can find the numbers easier. So because L equals a plus n minus 1d, and n will be your maximum number that you find the sum of. The sum of an AP can be written with sigma notation. So usually you might see this in maths when you're doing sequences and stuff. It just means the sum of. It kind of look a bit weird. It just looks like I don't know. It looks like a reversed 3 that's got really rigid limbs. I don't know. It's very weird, but you could say it's a very rigid E as well. But yeah, don't let it scare. It just means the sum of. It just means this sum of whatever equation you wanted to find. But I'm going to explain it further in the example that's next. So you might find an equation, a question in an exam, or I don't know. It could be just maybe some homework you've been set, or you might be doing it as a hobby. You know, I might have a question in a textbook that you just want to learn about maths. You know, you never know. You might find in a question like this. So it looks all a bit weird. It looks like so we have that sigma notation. So that just means the sum of. But so that's first of all. R equals 1. Now R equals 1 is it starts at R equals 1. So the very first number we're going to stick in is into where it says R will be 1. If it was 0, then you put 0 in. And then 5 is the nth value that it wants you to find the sum of. So it basically wants us to find the sum of the terms from the first term to the fifth term. That's a very bad. It just means nth value. Can you rub out with this? Yeah, eraser. I'll just write it a bit clearer. So this is the nth value. No, actually, it's not the nth value. It's the nth term, more specifically, because it can get a bit confusing. The value is the actual number of that term, but because so it'd be like 17, for example. nth term. So yeah, whatever. So n equals 5, then there'll be a value associated with that, because it can get a bit confusing. You can get confused with the nth term and the nth value. So remember that. So let's see what we do first. So first of all, find a, which is when r equals 1. So at the bottom of the sigma notation here, stick in r equals r, which is 1. So 3 times 1 add 2 equals 5, which equals a. So, and now find the other terms. So up to 5. But what I'm going to show you, two ways. I'm going to show you the way that the standard way of doing it that you would usually do in, like, for example, basic maths. Very like when you first learn maths, you learn how to add, don't you? It'll show you with so you can derive it from base principles, and you know I'm not lying to you when I show you the equation. And then we use that equation to find the sum, and then hopefully we'll get the same answer. Example 2 continued. So at r equals 2, so just stick in 2 now, and you get a value of 8. Stick in 3 for I equals 3, you get a value of 11. I equals 4, you get a value of 14. Yeah, I equals 5, you get a value of 17. So write out the sequence. So 5, 8, 11, 14, 17. So 17 is the nth value where n equals 5. So it's the number at n equals 5, basically. And n is the maximum number or the maximum term it wants you to find the sum of. So using standard notation, using standard maths, you can actually find that it equals 55. You just by adding them all together. So does it work with that equation I showed you? Or is it all a lie? Well, let's see. Alternatively, so 5, which is the nth term, not the nth value, the nth term, so 5. So 5 over 2, it's about 2.5. 5 add 17. So since 5 is the start number, A, and 17 is the nth value. So 5 add 17 is 22. 22 times 5 is 110. Divide that by 2 is 55. We did it. So I hope this was useful. I think that's the end, yes. Hopefully it was useful. I hope it gave you a very brief sort of introduction to sequences, more specifically arithmetic sequences or progressions. And I hope this was useful for you. I hope you all have a good day, and I hope you take care.